Welcome to The Explainer. Today we're pulling back the curtain on a really critical conversation that's honestly missing from the mainstream space right now. We're talking about which Layer 2 networks are actually going to survive the upcoming quantum transition. You know, most of the coverage out there is endlessly focused on throughput, transaction fees, and total value locked. But today, we're going underneath all of that. We're looking at their foundational cryptography and why there is a ticking clock that threatens to literally break it all.
Okay, let's kick things off with a number that is just staggering. $18 billion. That is the amount of wealth sitting entirely on just a single Layer 2 network right this second. Add another billion plus on its closest competitor, and when you look across the whole ecosystem, the total value secured runs well into the tens of billions. Every single swap, every loan, every mint you execute without paying $20 in gas fees happens right here. And altogether, it's creating the ultimate honeypot for a future quantum attacker.
But imagine if the invisible mathematical signatures that secure all those tens of billions of dollars just cracked, right? We are not talking about a simple bug in a smart contract or a glitch in a user interface. We're talking about the fundamental hashes that bundle thousands of your transactions into a single proof. Quantum computing isn't just a Layer 1 problem for Ethereum, it's a stack-wide reality that severely threatens the L2s built on top of it.
So here is our roadmap for today. First, we'll cover the hidden quantum threat. Second, optimistic rollups shared flaw. Third, ZK rollups, which are a bit of a wild card. Fourth, sidechains and state channels. And finally, we'll map out the concrete 5-year L2 migration timeline.
Starting off with Section 1, the hidden quantum threat and understanding Layer 2 cryptography.
To really grasp this threat, we have to look at why Layer 2s exist in the first place. Basically, they exist to compress transactions off-chain and then post the results back, bypassing mainnet congestion. Now, these 4 bullets are the core architectural types we're going to evaluate today. We've got optimistic rollups, ZK rollups, sidechains, and state channels. Because each one attempts to secure your data in a completely different way, each one has a totally distinct, unique quantum exposure profile.
Moving right along to Section 2, optimistic rollups shared flaw, specifically the ECDSA inheritance.
Okay, so what's really interesting here is the dual threat that optimistic rollups like Arbitrum, Optimism, and Base currently face. On the one hand, you have the inheritance problem. These rollups use ECDSA, which is the exact same elliptic curve cryptography that Ethereum mainnet uses to sign transactions. So when Ethereum's math becomes quantum vulnerable, these rollups inherit that vulnerability instantly. But on the other hand, we have a uniquely centralized threat, the sequencer. Until fully decentralized sequencers arrive, which is slated for between 2025 and 2026, a quantum attacker who cracks just one centralized sequencer's private key could completely manipulate transaction orders, extract value, and just blatantly censor users. So what does this actually mean for you? Well, the crucial takeaway is that holding your assets on an optimistic rollup is roughly equivalent in terms of long-term quantum exposure to holding them directly on Ethereum mainnet. Now, it's slightly worse because of that centralized sequencer dependency we just talked about, but it's also slightly better because their rollup data structures allow for somewhat cleaner software upgrades. But here is the truly alarming part. Arbitrum holds over 30% of Layer 2 DeFi total value locked, yet no major optimistic rollup has actually shipped a public post-quantum migration plan yet. They just aren't out there.
All right, on to Section 3, ZK rollups, the wildcard. A tale of 2 proofs.
Now, this is where things get really fascinating because there's a massive contrast within the zero-knowledge space itself. Basically, not all ZK proofs are created equal. We have a very clear divide here. On one side, we have quantum-vulnerable snarks. Snarks, which are used by networks like ZK Sync and Polygon ZK EVM, depend heavily on that same elliptic curve cryptography, leaving them completely exposed to Shor's algorithm, the quantum calculation designed to break traditional encryption. But on the flip side, we have Starks, which are totally different.
And that's because Starks, like the ones used by StarkNet, avoid that vulnerable elliptic curve math entirely. They are based on hash functions. This fundamental design choice makes Stark-based ZK rollups the most quantum defensible architecture in the entire ecosystem today. The proof system itself is largely resistant by design. Now, a quick caveat, your individual wallet signatures still use that vulnerable ECDSA math, so your account-level exposure is still there. But the overarching chains proof system, that is safe. And heading into a quantum transition, that is a massive, massive head start.
Next up, Section 4, sidechains and state channels, bridges and Bitcoin tunnels.
So Polygon is kind of its own beast because it's a diverse ecosystem of solutions. Their original proof-of-stake network operates as a sidechain. And look, Polygon consistently demonstrates they can execute deep protocol upgrades, like their recent Giuliano upgrade that drastically improved confirmation times. They have the technical capacity, but their bridge validators currently remain a prime target. Bridges hold massive pools of locked capital, right? A quantum attacker who derives the private keys for these bridge validators could potentially just mint unauthorized assets out of thin air. Until Polygon's unified ag layer fully rolls out to upgrade the security model, those sidechain bridges carry some serious risk.
And then we have the Lightning Network over on Bitcoin. For state channels like Lightning, the quantum risk is heavily layered into every single transaction commitment. Step 1, you have base layer risk the moment you lock up your Bitcoin to open a multisig channel. Step 2, every single time you sign an off-chain balance update, you're handing your counterparty a signature. And here's the real danger. A counterparty with a future quantum computer could look at those historical signatures and derive your private key. It's wild. This means Lightning needs an entirely independent migration plan, unless Bitcoin itself upgrades via proposals like Bit360 or 361.
Which brings us to Section 5. The L2 migration timeline. And yeah, the clock is definitely ticking on this.
So knowing all these structural vulnerabilities across the different architectures, exactly when does this theoretical threat become an operational reality? Well, this timeline marches us through the next 5 years. And let me tell you, the deadline for action is incredibly strict. In 2026, we expect STARKs to really pull ahead as the first public migration roadmaps finally emerge. By 2027, alternative snarks with quantum-resistant math should hit mainnet, and decentralized sequencers will advance. 2028, that's the tipping point. Regulatory pressure is going to force massive institutional migration, and we'll see the first post-quantum addresses go live. By 2029, the threat shifts from a lab theory to an operational reality, forcing legacy chains into chaotic emergency upgrades. And finally, by 2030, the bulk of active value should be secured, and the absolute worst exposure windows will close.
This actually brings us to a really powerful quote from the source material that just perfectly summarizes the real challenge here. Quote, "The question is not whether your assets are safe today. They are. The question is whether you are positioned for the migration when it comes. Your assets are totally fine right this second, but the true test is evaluating if the chain holding your assets actually has the technical capacity and frankly the political will to coordinate a deeply complex cryptographic upgrade in time to beat the quantum clock."
So I will leave you with that provocative thought to consider regarding your own portfolio as we wrap up this explainer. Are you positioned for the migration? Don't just look at the total value lock leaderboards. Look at the foundational primitives. Does the layer 2 that you use the most actually have a plan to survive what's coming? Something to think about. Thanks so much for joining me on this deep dive, and I'll catch you in the next explainer.